Assalamualaikum. Welcome to our GSC online classes. I'm ASM Dilzer before you. In our last class, we have discussed about theorem 1. So today's topic is about theorem 2. All you know that in our early classes we have discussed about vertically opposite angles. Do you remember? You should. Okay, no problem if you don't remember. So we are here about today we are going to discuss in brief of vertically opposite angles and theorem 2. Okay, so let's get started. So what really theorem 2 about? At first we will look into the question first. So what is about theorem 2? In the question it will be asked to prove that when two straight lines intersect, the vertically opposite angles are equal to each other. So it is required to prove that if two lines are intersected, then the produced non-adjacent angles, vertically opposite angles, are equal to each other. Okay, at first we should know what vertically opposite angles are. Okay, take a look here. We know that two straight lines can intersect only a point. So this is the point, it's the intersect point, and AB and CD are two lines. So what is vertically opposite angles? Here you can see if two lines intersect each other at a point, four angles are formed. 1, 2, 3, 4. So four angles are formed. Now you can see 1 and 2. These two are adjacent because they are lying next to each other. 1 and 4. These two are also adjacent because they are lying next to each other. But 1 and 3, these two are not adjacent angles. So 1 and 3, and 2 and 4. These two pair are called vertically opposite angles to each other. So what is the definition of vertically opposite angles? So vertically opposite angles are when two lines intersect each other at a point, produce non-adjacent angles, are called vertically opposite to each other. We know that vertically opposite angles are equal to each other, but it's time to prove that they're equal to each other. We are taught about that vertically opposite angles are equal to each other, but we don't know how to prove it. In which way we can prove it? Today's topic is our theorem 2. So all we have to prove that these vertical opposite angles are equal to each other when two lines are intersect. Okay, so let's get started. At first we will go through the question. So what is the question? If two lines intersect each other at a point, prove that vertically opposite angles are equal to each other. Okay, so this is particular enunciation, so we'll draw the figure now. What need to draw? We need to draw two lines, and these two lines will intersect each other at a point. AB and CD. AB and CD are two lines and they intersect at a point O. Now what are the vertically opposite angles AOD, BOC. This pair is vertically opposite to each other, and this pair AOC and BOD, this pair also vertically opposite to each other. So it's equal to prove that these two and these two are equal to each other. Okay. Now, in your primary enunciation, what will you write? Let AB and CD are two lines which intersect each other at O. As a result, so which four angles are produced? Take a look. AOD, BOD, BOC and AOC. These four, right? As a result, AOD, BOD, BOC and AOC angles are formed. So what need we to prove? It is required to prove that it is required to prove that AOC is equal to vertically opposite to BOD and this two. AOD is vertically opposite to BOC. AOD is equal to vertically opposite to BOC. Okay, so it's our primary enunciation. Okay, I am marking what we need to really prove. Okay, these two will prove. Now, so here no additional drawing is necessary or required, so we'll just jump into proof. Proof. At first, it's so much requirement is that you have to know theorem 1 first before going through the next step. So if you don't know about theorem 1, go back to theorem 1 first and read it out carefully. After that, come back to theorem 2. Here, take a look here. In our theorem 1, what have we taught? We are taught that if a ray meets a line in a point, then produced sum of the adjacent angles is equal to 2 right angles or 180 degree, right? Here, suppose OB is omitting. Okay, OB is omitting. So what will be the rest of the figure? O here, OA, right? Just let OB is not here. So this figure will be like this in case of OB is not here present. Okay. So compare this figure with our theorem 1. This is a line, this is a ray. This ray meets the line at O. As a result, 2 adjacent angles are formed. So what is the sum of these 2 angles will be? Of course 180 degree, right? So we'll write this here. Ray OA meets CD line at O. Therefore, AOC plus AOD is equal to, so two right angles is equal to what? 180 degree, right? So in case of two right angle, we can also write 180 degree. After that, in our first case, OB were omitted. Now OC will be omitted. Okay, let AB and OD is ray and OD ray meets line AB. So OC here omitting. Okay, so let OC is not present here. So what will be the figure after omitting OC? So the figure will be like, this is AB, one side will be here, D here. So this is also like the theorem 1. OD ray meets line AB at O, so that two adjacent angles are formed, and sum of these two adjacent angles will be 180 degree. So OD here a ray, AB is a line. So when a ray meets a line at a point, sum of the two adjacent angles is equal to 180 degree. From the theorem 1 we have taught that. So we'll write the same thing here. Again, ray OD meets AB line at O. Therefore we can write this sum of these two, this and this, AOD plus BOD is equal to 180 degree. Okay, now so I don't have enough space down here, so I'll write in the right side, you guys write down. Okay, now one thing I will clarify. Suppose I have told you 7 plus 3 is equal to what? What you will answer? Your answer will be 10, right? If I asked you 4 plus 6 equal to what? The same question. Okay, so answer is the same, it's 10. So what is the what is the purpose of writing these things? Okay, again here, if I write 5 plus 5, then answer will be the same. I'm repeating the question why, right? Here, take a look here, listen very carefully, sit straight. 7 plus 3 equal to 10, 4 plus 6 equal to also 10, and 5 plus 5 obviously is sum of 5 and 5 is equal to 10. But what is the reason behind writing the things here? Listen carefully and take a look here carefully. One side of equation, the three equation I have written here, and among the three equation one thing is common. So what is the common thing? All you know that the right side of the equations are equal. If, remember one thing, and always remember this, that among the equations, if one side is equal, then the other side will also be equal. Here 7 plus 3 is 10, 4 plus 6 is 10, 5 plus 5 also 10. For being the right side equal, left sides are also will be equal. That's why. Okay, here take a look. The purpose of writing the things is here. This one and this one, these two are, you can see, these two are equations, as there is equation sign, equal sign is here, and left side and right side, take a look here, 180 degree and 180 degree is the common things between the two equation. That is the why the left side will also be equal. So we'll write this AOC plus AOD will be equal to AOD plus BOD, right? Why? Because right side is equal between the two equation. Right side is equal, so that left side will also be equal. So right here, therefore AOC plus AOD angle AOD is equal to AOD plus BOD. AOD plus BOD. Or, okay, take a look here in the right side of the equation and left side of the equation. What can you see? Is there any common things between the two sides? Of course there is a common thing. So what is the common things here? Here is also AD AOD and here is also AOD angle, right? So if we omit AOD from both sides of the equation, what will be the left? And first write omitting AOD from both sides, we get what we get? AOC is equal to BOD. AOC is equal to BOD. Listen carefully and take a look here. AOC is equal to BOD. What was our first thing to prove? AOC will be equal to BOD, right? AOC is equal to BOD. AOC is equal to BOD. Have we proved? Yes, we have done. Now, in a similar way, we can also prove that AOD is equal to BOC. How? Here, take a look. In the left figure and the right figure, these two are additional figure. Not necessary. For understanding purpose, we have drawn this. Here, at first, when I took OA as ray, the opposite ray were not present in the figure, right? And here, when we took OD, opposite of OD is OC. OC is not present here, right? So we will just reverse the thing. We have taken OA, so we will not take OA. When we are going to prove AOD is equal to BOC, we will take OB. In case of OA, we will take OB. So OA will be omitted. After that, we have taken, we took OD and OC were not present here. So when we are getting reversed, then OC will be present and OD will be omitted. After that, we will get the same things. We will get the result that AOD is equal to vertical opposite to BOC. It's not necessary to write, just to write what? Similarly, we can prove that. Similarly, we can prove that, right? Similarly, we can prove that. What we can prove that? AOD is equal to what? BOC. Proved. So, my dear students, is there any question? I think you got it. If you don't got it, if you don't get it, so revision this theorem 2 again and again so that you can understand the thing, the topic of the thing in detail. I have discussed. If there is, even if there is any problem, then you can contact with me. You know my number, so you can contact with me so that I can help you. Okay, so now today, see you again in our next class. So till then, Allah Hafiz, see you again, bye.